All right, so we are going to continue with section 1.1, and today this is going to be our introduction to solving equations, simple equations. We'll start out with just simple 1 and 2 step and kind of move on, but first we got to get some terminology out of the way and some notes. This is solving simple equations. And we are going to do that using inverse operations. So here we go. Let's take a look at these. Couple of definitions. First one, inverse operations, or an inverse operation, is simply nothing more than using the opposite operation. And when I'm talking about operations, I'm talking about the 4 that we will use, the only 4 there are: addition, subtraction, multiplication, and division. If I have addition, the inverse operation is subtraction. If I have subtraction, the inverse operation is addition. Multiplication, the opposite of multiplication is division, which makes the opposite of division multiplication. We have a whole bunch of properties that we use doing this. The addition property of equality. Addition means add, so what we want to do is add the same number to both sides of an equation. And this is a very important point that's going to be repeated throughout this lesson. With equations, they need to be equal on both sides of the equation. What I do to one side, I must do to the other. That equal sign in the middle means balance. They need to be balanced. I can't just add something to one side of the equation without adding it to the other, because it makes it unbalanced, and that equality between the two sides is no longer there if I don't do it to both. Here's what it looks like algebraically. If A and B are the same, meaning I have the same on both sides, if I take A and I add C to it, and I add that same C to the other side, I have not changed the value of that equation. Of course, you guys can probably figure out subtraction is what's next. So my subtraction property, I simply subtract. We're subtracting, the action of doing it, the same number from both sides of an equation. It's a subtraction property. And again, if I have A is equal to B, and those are on opposite sides of the equal sign, it just simply means I don't change the value of that equation if I subtract C from both sides. What I do to one side, I must do to the other, and those need to stay balanced. Let's take a look at a couple examples of those two. Here I have a simple equation, x subtract 3 is equal to -5. Little one-step equation. Here, I would want to use the addition property because what I have is subtraction and I want to do the opposite. What I do to one side of the equation, I must do to the other. This equation is simply saying I have some number x, and when I subtract 3 from it, I get -5 as a solution. And I want to know what this value of x is. All I need to do is add 3 to both sides of the equation. My x stays the same. -3 plus a 3, that's 0. That's what I'd like. And then -5 plus 3 is going to give me a -2. And I can certainly check that. If I substitute what x equals in right back here to my original equation, -2 subtract 3, does that equal -5? Well, -2 minus 3 certainly does. Makes this -5 equal -5. That checks, and I know I did this problem correctly. Another quick little example here. Let's say I have 0.9 is equal to y plus 2.8. Again, the idea is always going to be to solve for what variable? Whichever one's given in the problem. Y is being added by 2.8. This is addition. I need to undo that addition. I need this y to get by itself. And if I subtract 2.8 from both sides of the equation, that will leave me with y by itself. So I'm going to subtract 2.8, subtract 2.8, stay nice and organized. Now I have a positive 0.9, subtract 2.8. Well, that would be closer to 0. I'd add 0.9, negative 1.9. Y stays, and that's 0, and that's what I'm looking for. I can always go back and check this. There's no reason not to check your equations. Anytime we're solving equations here in algebra or pre-algebra, we can take whatever our variable equals, plug it back into the original equation, and see if our answer gives us a true statement to see if I've done it correctly. So in this case, on my check, I'm going to have 0.9 is equal to what I found out y to be, which is -1.9 plus 2.8. I could take my calculator and add that up. But -1.9 plus 2.8 or 2.8 subtract 1.9 is indeed 0.9. 0.9 equals 0.9. It checks. And I'm going to box in that answer. And I probably should have boxed this in too after I checked it. So there's addition and subtraction properties. I'm going to start a new page here because we're going to get into the last two, which are multiplication and division. All right. So we'll look right here, the multiplication. Multiplication property. It would be exactly what you would think it would be. This time, though, we are going to be multiplying. Each side of an equation by the same number produces what we call an equivalent. Equation. And again, we're just going back to that concept that we talked about earlier, where if I do the same exact thing, the same operation to both sides of an equation, I do not change the value of that equation. Remains balanced. If A is equal to B, then A times C is going to be equivalent to B times C. In this case, though, we don't want C to be 0. If C was 0, both sides would be 0. We wouldn't be able to solve it. If I multiply the both sides by the same number, I don't change the value of it. And the last one we're going to look at, the opposite of multiplication is division. So this is the division property. And it would be exactly what you would think. Dividing each side of an equation, dividing each side of an equation by the same number, has to be the same. By the same number, just like with multiplication, this produces an equivalent equation. Again, an equivalent equation means I change it, but I don't change the value of it. It's the same as when I started. If A is equal to B again, then I can certainly say A divided by C would be equal to B divided by C. And again, C cannot equal 0. We cannot have 0 in the denominator. We don't want that. If you put that into your calculator, we call that undefined. And we will certainly revisit that several times throughout the year. So here's a few examples. We'll call this example, and we'll just call this one letter A. I have negative, or the opposite of n, divided by 5 is equal to negative 3. So I have some number divided by 5, and that's going to give me a negative 3. Well, I can tell right now, I know that the answer has to be 15, because 15 divided by 5 gives me 3, and I have a negative 15. Negative divided by a positive would give me a negative. I know that's what it is. But what we're going to do is use our multiplication property here. If negative n is being divided by 5, or if I have negative n over 5 or n over negative 5, however you want to look at it, if n is being divided by 5, I need to multiply that by 5, and more specifically, I want to use a negative 5. That way I don't have a negative variable. Here's where the property comes in. I have to do it to both sides. So if I multiply this side by negative 5, I have to multiply this side by negative 5. That gives me an equivalent equation. It doesn't change the value of it. And now you would have negative 5 times n, or negative 5 divided by negative 5, however you want to look at it. This would be negative 5n divided by a negative 5. That would leave me with a positive n is equal to negative 3 times negative 5. Negative times a negative would leave me with 15. That would be my answer. I can go back and check it. Negative 15, because n was equal to 15, divided by 5, I want to know, does that equal negative 3? Well, I can certainly put it in my calculator, but hopefully I know negative divided by a positive would give me a negative, and certainly 15 divided by 5 is negative 3. So negative 3 equals negative 3. It checks, and I will box in this answer right here of n is equal to 15. Let's look at letter B here. Whoops. Sorry about that. Here I have pi, that irrational number pi, 3.14 dot 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 goes on forever. I have pi times x is equal to negative 2 pi. Let's say I was solving for x. We're going to say solve for x. We still are going to treat pi just like it was some sort of variable. We want to solve for x, which means I can certainly divide by pi if x is being multiplied by pi. So if I am looking to isolate x or get x by itself, x is being multiplied by pi, that means I would divide both sides by pi. Perfectly legal to do something like that. Anything divided by itself is 1. That's what I want. That's the exact same thing that happened over here. The pi's divide into each other, and x is equal to negative 2. I just put that one in there because there's going to be some in your homework that look like that, where we have pi or some other symbols in there. Just treat them like it's a number itself, divided into itself. We want to get rid of it or clear it to the other side of the equation so we can isolate that variable. There's your multiplication. The next two examples we'll look at is division. Here I have y divided by 3, or y over 3, is equal to negative 6. Meaning some number divided by 3 is negative 6. And it's those of us that are good at mental math, I know that that number y has to be 18, because 18 divided by 3 would be 6. And more specifically, because this is negative, this has to be negative 18. We're going to solve this, though, just like what we're going to be doing when we're solving our equations, showing our steps, showing that we know how to solve one-step equations that involve division. If y is being divided by 3, I want to use the inverse operation of that division, which is multiplication, which means I would multiply both sides by 3. And remember, this is 3 over 1. And you can think of this however you want. I can multiply straight across when I'm multiplying fractions. That would give me 3y over 3. Or I want you guys to really get in the habit of just saying, hey, if I multiply by 3, the reason I'm doing that is so those divide into each other and just give me 1. This is y over 1. We don't write that. We just write it as y is equal to negative 6 times a positive 3 would give me a negative 18. And I can certainly check that. I can take that negative 18, plug it right in for y, divided by 3. That should equal negative 6. Put that into your calculator, hopefully not, just use mental math. That checks. I'll box it in. Next example here. If we go 9 pi is equal to pi times x, back up to multiplication here. If I want to solve for x, it's being multiplied by pi. The opposite of multiplication is division. I would divide both sides by pi. 9 is equal to x. Doesn't matter which side this goes on. If you don't like writing 9 is equal to x, well then write x equals 9. Last example, we're going to do a little decimal here. I have 0.05w is equal to 1.4. W is being multiplied by 0.05. To undo multiplication, I use division. It's inverse operation. So I would divide both sides by 0.05. 0.05. I would plug that into my calculator, and W equals 28. Before I box it in, I'm going to check it. 0.05 times 28. Actually, we shouldn't be using that X there. From here on out, we'll either just use parentheses or a dot. I'll use parentheses this time. If I plug that in real quick, I indeed do get 1.4. I will box that in. W is equal to 28. You don't need to write the W there. I would prefer that if we'd write that as W is equal to 28. And that is it. We should be able to practice some simple inverse operation problems using multiplication, division, addition, and subtraction.